Hello world, Leon here, and this is wrapped rows on Oasis Sapphire. And the idea of this is to create confidential wrapped rows. Codename is bouquet. So why should we do this in the first place? So the problem is, with DeFi protocols, such as Uniswap, all the tokens have to be a certain standards. For example, an ERC20 token. So if you were to transfer rows to another token, you'd have to first wrap it to have all of the functionality of an ERC20 token to be able to do these DeFi swaps. So that's the first thing. The second is even though Sapphire Paratime provides a confidential state, it does not have confidential transfer of rows. So for example, if I have a game, I can keep the state confidential. That's great. But as soon as I transfer rows from me to you, that's recorded on chain, and you can actually see how much I'm sending. So let's try to solve this with a solution using wrapped rows. So using wrapped rows, it makes an ERC20 token. So you can use this in any DeFi protocol. And with this contract, there will be a metaWithdraw function that allows gasless and confidential transfer of rows. So everything from state to the rows itself is gasless and confidential. So I'm going to go over how wrapped tokens work in a general sense, and then we'll go into the metaWithdraw. So in order to interact with the contract, the first thing you do is deposit. So let's just say Alice has 9 rows and she wants to deposit into a contract. She calls a deposit method with 9 rows into this contract. Once it's deposited, Alice now has 0. Let's just say she's maxed out at 0, and the contract now has 9. So now that it's wrapped, you can do your DeFi protocol. Let's just say you want to undo it. So to undo it, you call the withdraw function. So Alice now has 0, right? The contract has 9. She calls the withdraw function. And once that's done, the contract will send the 9 rows back to Alice. She's happy. Keep in mind that in order to do this, Alice has to pay a transaction fee. Even though it's small, it is something. The third is the transfer. So let's just say Alice deposits the 9 rows, and instead of withdrawing it, she wants to send it to Bob. So once it's deposited, Alice can call the transfer to Bob, and the balance would go from 0 to 9, right? Pretty basic. Now, here's the interesting part. Let's just say Bob has the 9 rows, and he wants to withdraw it. Well, if Bob has a balance of 0, let's just say it's a fresh account, he won't be able to withdraw the funds because he needs a transaction fee, a little bit of rows to actually call the function to withdraw. So he's basically stuck until somebody gives him a little bit of rows to withdraw the funds. So how do you solve that? Well, you can solve it with the metaWithdraw function. So with the metaWithdraw function, you can confidentially, I think that's a word, send rows without paying for gas. Right? So here's a little table explaining how it does the mechanism. So they're both fast, right? Withdraw and metaWithdraw. Confidential withdraw, it's not, right? If I send token rows to somebody else, you can see that on chain. With metaWithdraw, it is confidential, and it's gasless. So Alice or Bob would have to call a function and pay gas to withdraw. With metaWithdraw, there's a relayer that actually pays the gas for you, so you don't have to pay any of the fees. So here's a more detailed version of how it works in text form. So let's just say Alice wants to send rows to Bob in a gasless and confidential way. The first thing she does is she wraps the rows to get wrapped rows, right? You can end here and interact with your DeFi protocol, but if she wants to send it to Bob, the next thing she does is she creates a meta transaction that says, hey, I want to withdraw funds to Bob. Once it's created, she can sign it. This is where MetaMask pops up, and you can sign it. There's no fees. You're not interacting with the chain. It's just signing a piece of data. And once that's done, you send it to a relay. The relay then submits the signed meta transaction plus gas, right? So the relay is paying for the gas to do the withdrawal. Once that's done, the contract will release the rows to Bob. Bob's happy, and the rows would be in its native form. So not wrapped rows, but actually rows. So now Bob does not need rows to unwrap his token. He gets the rows directly, and he is happy. Cool. So this is the written form. Here is a diagram, same concept. So Alice has 9 rows and wants to send it to Bob. First, Alice creates and signs a meta transaction. she then sends the signed meta transaction to the relayer. The relayer then submits the transaction and pays the fees. The contract with the 9 rows then says, okay, this is valid. Let's release the funds to Bob and pay a little bit to the relayer. All right, so that's the high level, and let's see this in action. So here's the contract. It's deployed, and we can check out the addresses. So we have a few addresses here. Just to get a reference, the first address is Alice. So it's DA06, which is my MetaMask account. DA06, this is Alice. So Alice has some funds. If I were to copy this address and check out balance of, you see that she has 9 wrapped rows already in the contract. Cool. Next is Bob. So Bob is 5B3, which is here. He has 100 rows, and the relayer 8B8 also has 100 rows. So the idea is I want to send Alice, send to Bob some rows. So let's get it started. So the first thing Alice should do is create the metaWithdraw transaction, which is here. So in here, it says, who do you want to send this to? I want to send this to Bob, so I'm going to copy this address. The amount is going to be, let's just say, instead of 9, let's just say 8. The nonce is 0, so this prevents any replay attacks. And the reward is going to be 1. So this is the amount being sent to the relayer. We'll just keep this 1 rows for now, just for simplicity's sake. Okay, now I'm going to call, and it's going to create a hash of this transaction. So I'm going to copy this transaction, and I'm going to sign it. So I'm going to go to the really fancy Oasis wrapped Sapphire Rose meta transaction signer, paste this in, make sure that I am Alice. That's great. And I sign it. So I'm Alice, and I sign this data. And this data basically says, yes, I approve sending this amount to Bob and the relayer. So hit sign. And this is the sign message. I then copy this, go back to the contract, and I can call the metaWithdraw function here. So the signature, I'm going to paste in the signature. And I'm going to copy this information directly from here. So I'm going to say 2 is to Bob, right? The amount is this much amount to Bob. Nonce is 0. And the reward is going to be this much. Cool. So now I'm going to switch to the relayer account because the relayer is going to pay to interact with this transaction. So I'm going to switch to the relayer, so AB8, right? So AB8 is here. And I'm going to, the relayer is going to pay for the transaction. So I'm going to hit transact. Hopefully things turn green. Great. Now, if I check the balance of everyone, you can see that Bob, 5B3, has the 8 rows. He's happy. And the relayer also has the 1 rows from the fee. So he's also happy. And that's how it works. As you can tell, with the MetaMask, Alice didn't have to sign or broadcast any transactions. This is done via the relayer. So that's how it's done. Thank you.